Hi everyone, welcome back to my channel Math Monsters. This is the fifth and last video of our counting and probability series. So far we've learned several amazing skills such as the addition principle, the multiplication principle, all the way up to some complex problems using permutations and combinations. All of that really built up to what we are uncovering today, and that is probability. Probability questions usually have factors like the total number of outcomes, the favorable outcomes, and counting really is the foundation of figuring out those total number of outcomes and factors like that. So yeah, without further ado, let's get right into the questions for today.
Okay, to start off, let's do something a little bit simple. So you roll a six-sided die and you want to know the probability that you will roll an even number. So we know that in a six-sided die, it contains the numbers 1 through 6. So 1, 2, 3, 4, 5, 6. And you want to know the probability that you will roll an even number out of those 6 numbers. So the even numbers in these 6 are 2, 4, and 6. And how probability works is that you express it as a common fraction. Usually, if it asks you to express it as a percentage, then you would make that fraction into a percentage. But in this case, let's just stick to a fraction. So basically, the numerator of the fraction is the favorable number of outcomes. So I'm going to write favorable outcomes. And the denominator is the total number of outcomes. All right, so our numerator in this case is the favorable outcomes, which is the number of even numbers out of the total. So we have 3 even numbers, so the numerator of this fraction would be 3. And the total number of outcomes is, of course, 6 because there's 6 total numbers in the die. So probability is expressed like the favorable outcomes over the total number of outcomes. When you simplify this fraction, which you always have to do, you get 1/2, and that will be our final answer. Let's move on to something a little trickier. Alright, our next problem is, in a six-sided die, what's the probability that you roll a number greater than 4? And this problem's pretty much like the first problem. So we can start off by writing the numbers 1, 2, 3, 4, 5, and 6. And they're asking what's the probability that you roll a number greater than 4. So greater than 4 is 5 and 6. So that is 2. And that will be our numerator, remember, because our numerator is the favorable outcomes, and the denominator is our total outcomes. So again, our total outcomes would be 6 because, oh, my bad. 6 because we have 6 total outcomes. And when you simplify this, we get 1/3, and that is our final answer for this problem. Okay, here's our next problem. A 3-digit code is made using the digits 0 through 9, and digits can repeat. That's a typo. It's supposed to be, what is the probability that the code ends in an even number? I'll just change that to the. Okay. So I think what we should do in this case is figure out the total number of 3-digit codes possible. And to do that, I'm going to just write down my 3-digit number. I wrote 1 space for each digit, and it's using the digits 0 through 9. And what we notice is that each digit has 10 possibilities since there's 10 digits from 0 through 9. And this is an AND scenario, so we will be multiplying the possibilities. For the second digit, also we have 10 possibilities, and for the last digit, we have 10 possibilities since we can repeat digits. And this is nothing but 10 cubed, which is 1,000. So our total number of outcomes is 1,000, and I'm just going to put that aside. And now let's try to find the numerator. And the numerator is the favorable outcomes. And in this case, the favorable outcomes is the probability that the code ends in an even number. So how many even numbers are there from 0 through 9? There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the even numbers here are 0, 2, 4, 6, 8. So that's 5 numbers right there. So for the last digit, we would have 5 possibilities. So for the first digit, we have 10. For the second digit, we have 10. But for the last digit, we have 5 because it has to be an even number. Remember, we're calculating the favorable outcomes. So when we solve this, we get 10 times 10 is 100, times 5 is 500. So 500 will be our favorable outcomes. All right, and of course we have to simplify this fraction. So our final answer would be 1/2. All right, let's move on to our next question. Okay, you randomly choose 3 people out of 5 to be on a team. What is the probability that Alex is on the team? And we've done several questions like this, choosing teams out of the total number of people in past videos, but we've never really tied this to probability, so let's see how we do that. First, let's figure out the total number of teams that are possible, and this is something we've done in previous videos. So we use the combination formula to figure out how many people out of 5 people can you choose to be on the team. Well, they already gave that to you. How many teams can be possible? And the combination formula is n factorial over r factorial times n minus r factorial. And just saying, the reason we're doing combination is because there's no really rules within the team that affects the order. It's just the number of people. So n would be 5. Since there's 5 total people, I'm writing 5 factorial. And r factorial is 3 factorial. And n minus r is 5 minus 3, which is 2 n factorial. So to simplify this and make it easier, I'm going to write 5 times 4 times 3 factorial over 3 factorial, 2 factorial, so that these cancel out. And 2 factorial, of course, is just 2. So this simplifies, and we're left with 5 times 2, which is 10. So I'm just going to keep that aside. Now we want to figure out the favorable outcomes, which will be our numerator. A favorable number of outcomes is the probability that Alex is on the team. So if Alex is on the team, then already 1 spot out of the 3 people team is already occupied. So we only have 2 more people to choose. And how many people do we have to choose from? Well, since Alex is already on the team, out of the 5 people, 1 person's already on the team. So we only have 4 more people to choose 2 people from. So again, we'll be using the combination formula, but this time n would be 4 and r would be 2. So using the same formula, I'm not going to rewrite it. I'll just use it the same formula. So n would be 4, so 4 factorial, and r, like I said, would be 2. So 2 factorial, n minus r would of course be 4. I'll just make that a little easier to read. N minus r would be 4 minus 2, which is 2. So factorial. 4 factorial can be written as 4 times 3 times 2 factorial. So of course it cancels out one of the 2 factorials in the denominator. So I'm just going to write 1 2 factorial. Oh, my bad. So this also goes away. And 2 factorial is 2. So these cancel out. And you're left with 2 times 3, which gives you 6. So 6 is our favorable outcomes, and 10 is our total number of outcomes. So when we show this as a fraction to show the probability, of course, we write it as 6 over 10, which of course simplifies to 3 over 5. And that will be our...
Alright guys, we have reached the end of the video. I really hope you enjoyed it and learned something new from this playlist, because we really have been through a roller coaster of topics in this 5 videos. We started off with the addition principle, multiplication principle, we learned some new formulas, and permutation and combination. So make sure you really are practicing these skills, because that's the only way it'll be ingrained in your head and you can use them in competition math and math tests and so on. And if you found this video or this playlist useful, please make sure to subscribe to the channel and comment down below what was your favorite topic, and like this video, and yeah, share with your friends, and I'll see you in the next one. Bye!